We're going to finish up topic 4.1 with these last two examples here. We are still solving by and using our zero product property. I'm noticing on this one that it looks like, because I do not want to multiply 7 times 175, but I do know that 7 divides all those, so I'm going to take out a greatest common factor first. So I take out a 7, which leaves me with x squared plus 10x plus 25 equals 0. Before I go to factor this, I'm actually going to divide everything by 7 and move that 7 to the other side. So I've got x squared plus 10x plus 25, and then 0 divided by 7 is 0. That's a little bit different than what we have done before, because typically we'd want to write that down. It's because we're solving it, so we have to get the x by itself. I'm going to go ahead and do my good old magic x. So two numbers that multiply to 25 and add to 10 would be 5 and 5. And then the good news is because I took out the greatest common factor, I don't have a box, so I can just write it as x plus 5 times x plus 5 equals 0. Doing zero product property, I have x plus 5 equals 0 and x plus 5 equals 0, which makes it, if I'm going to subtract 5 from both of them, I really ended up with the same answer twice. A preview of what that looks like on the graph is it really means that your graph is bouncing off the x-axis. We call it a double root. All right, in example 20, hopefully you notice something a little bit different. It's not equal to 0. It needs to be equal to 0 in order for us to use the zero product property. So I'm going to start by adding 2 to both sides. We've got x squared minus 3x plus 2 equals 0. I am going to do a magic x. So I need two numbers that multiply to 2 and add to 3. That would be 2 and 1, both of them negative. So we've got x minus 2 times x minus 1 equals 0. I don't have a leading coefficient, so I'm going to go right to my zero product property. So x minus 2 equals 0 and x minus 1 equals 0. So x equals 2 and x equals 1.